Hello, it's A-level maths student here, and in this video I'm going to show you proof by contradiction. I'm basically going to show you that root 2 is an irrational number. Now, just to start off with, a rational number is a number which can be expressed as a fraction. 1 over 2, 3 over 2, 5 over 6, 6 over 7. So for proof by contradiction, what we do is we assume that it is true and show that it is nonsense. So we are going to let root 2 equal p over q, where p and q are integers. It must also be said that this p over q format represents root 2 in its simplest form. So we can now infer from that that 2 equals p squared over q squared, meaning that p squared equals 2q squared. Q is an integer, which means that q squared is an integer, which means that p squared is 2 times an integer, meaning it is an even number. Even times even numbers equal even numbers, and odd times odd numbers equal odd numbers, which means that if p is an integer and p squared is even, p must be an even number. So we are going to call p 2m, where m is half of p and m is an integer. So now we can say that 2q squared equals 2m all squared equals 4m squared. Next we can say that q squared equals 4m squared over 2, which as you can see simplifies to 2m squared. Using the same logic, m is an integer, so m squared is an integer, so 2m squared is an even integer. Q squared is even where q is an integer, which means that q is even. So we can say that q equals 2n. Root 2 equals p over q, so we can say that it equals 2m over 2n. Hang on, 2m over 2n can be simplified, but we explicitly stated that p over q was its simplest form. We have skew, which is mathematical notation for nonsense. If you don't believe me, then repeat the procedure for root 2 equals m over n. You get the exact same result. And this would imply, if you were to repeat it again and again and again, that root 2 could simplify forever. This contradicts the very rules of fractions, so it must be irrational, because if it was rational, it would not make mathematical sense. This was A-level maths student. Thank you for watching, and please check out some more of my videos.